Good morning, students. Yesterday we discussed about some of the basics about P block elements, and today we shall continue our discussion on P block elements. In log form of the periodic table, P block elements lies from group number 13 to 18, where partly p orbital starts to fill. Different chemical trends we discussed yesterday are electronic configuration, atomic and ionic radius, ionization enthalpy, and electron gain enthalpy of these elements. See, in log form of the periodic table, from group 1 to 2, which are called S block elements, from 3 to 12 are called D block elements, and 13, 14, 15, 16, 17 and 18 group elements are called, particularly from 13 to 18, these are called P block elements. So in first PU, you studied about 13 group as well as 14 group elements, their fundamental characteristics and some of the compounds. And according to your syllabus, we have to study 15 group elements, 16 group elements, 17 and 18 group elements. Is electronic configuration, atomic and ionic radius, ionization enthalpy, and electron affinity or electron gain enthalpy. See, electronic configuration of P block elements, which has a general electronic configuration ns2, np, 1 to 6, where the p orbital starts to fill from 13, p1, p2, p3, p4, p5, and p6. This is nothing but the 18 noble gas elements. Then atomic and ionic radius. See, along the period, atomic radius decreases due to increase in nuclear charge. Ionization enthalpy, it also increases along the period. Because nuclear charge increases, size decreases. So electrons are tightly held towards the nucleus. So ionization enthalpy along the period increases. And if you go along the group, ionization enthalpy decreases. Because period onwards, from second period, third period, fourth period, an extra shell it adds, and electrons are away from the nucleus. So electrons can be easily taken out by applying a small amount of energy. So therefore, ionization enthalpy decreases down the road as size increases. Then we studied about electron gain enthalpy. See, electron gain enthalpy is nothing but when an electron is added to a neutral gaseous atom, certain amount of energy is available. That is called electron gain enthalpy. Again, it also increases, electron gain enthalpy also increases along the period. Again, it is nothing but the more nuclear charge and small size. Then we have to study electronegativity. Today we shall discuss another concept which is called electronegativity. To study in first view, what is electronegativity? It is tendency of an atom to attract shared pair of electrons towards itself, towards it. When the compound is formed by two atoms, both the atom has certain electronegativities. So electron cloud distribution, it is nothing but electronegativity is nothing but tendency of an atom to attract shared pair of electron towards it. So by knowing the electronegativity of different compounds and different elements, take for example in HF. So it is a compound hydrogen fluoride. Here, fluorine is more electronegative. The electron cloud is more towards fluoride, more towards fluoride. This tendency is called electronegativity. In entire periodic table, the 17th element, fluorine, fluorine has highest electronegativity. Its value is 4, -4. You take next oxygen nearly 3.5, then nitrogen, chlorine, and these are four elements which shows more electronegativity. See nearly it's a value may vary, but oxygen can show 3.5 and nitrogen 3.1 and chlorine nearly 3. From compound to compound, electronegativity, a small value can change. Okay, these are highly electronegative elements where which can attract the shared pair of electrons towards it. Okay, this is nothing but electronegativity. If you go for the trend in periodic table, again electronegativity increases along the period and it decreases along the group. Particularly for P block elements, electronegativity is more along the period. As you come down the group, in 15 group, 16 group, 17 electronegativity decreases. Okay. So, electronegativity is another important criteria. As electronegativity decreases, the positive character increases. The lower elements in the P block elements may act as a metal. We can find many changes. All P block elements are non-metals, but we have here metals, non-metals, metalloids. That diversity is due to the four important characteristics: electronegativity, electron gain enthalpy, and small size, that means atomic size, and ionization enthalpy. These are important trends where P block elements characteristics can be studied. That is the basic thing you have to remember. So actually we have a syllabus which shall discuss in this class. So we shall have other concepts which you have to remember in P block elements. See, if you see, this is nothing but a second period element: nitrogen, oxygen, fluorine, and neon. So next we have phosphorus, sulfur, then chlorine, argon. See, this is nothing but a second period element and third period element, like that it goes on continuous. So nitrogen, phosphorus, arsenic, antimony, bismuth. Again oxygen, sulfur, selenium, tellurium, polonium. Yesterday we got chlorine, bromine, iodine, aspartame. So helium, neon, argon, krypton, xenon, radon. You must know these elements. Okay, here as you come down after third period, that means from fourth period onwards. So there is an addition of D and F orbitals. D and F orbitals. That it may be 3D, 4D, 5D. See, these, if suppose this is an atom, and we can find any shells or the orbitals as we come down, See how nitrogen is a non-metal, and generally you know bismuth is a metal. Arsenic and antimony are metalloid. Like that is the trend. Generally, what we observe p block elements are non-metals. No. Why there is a diversity in p block elements? That diversity is due to some reasons. Those reasons we have to study. We have to pick that point. Okay. See, if suppose this is nothing but a nucleus and number of orbitals we can find. See, we can find the presence of inner core electrons, either by p orbital or by s orbital. This is nothing but the influence of nucleus and outermost electron, which is nothing but a nuclear charge. Due to the presence of number of orbitals, the force between nucleus and the electron get reduced. That reduction of force due to the presence of orbitals or shells, and this is called screening effect. It's called screening effect or the shielding effect. So this shielding effect gives there is a lot of difference in properties of p block atoms. As there is a diversity due to screening or shielding effect. What do you mean by shielding effect? The number of subshells in the, as we come down in the group, the higher elements. So, due to the presence of D and F, this is what a core shielding. Large number of electrons are there in D and F. These are called inner electrons. These inner electrons and the shells make an influence between the outermost electron and the nucleus. So, this nuclear charge get reduced due to the presence of different orbitals, either D or F. And that particular effect is called screening or shielding effect. Sometimes the shielding effect is very poor, then at that time nuclear charge is more. Okay. Like that, you have to remember another point. Inert pair effect. Inner pair effect. Say it is nothing but a second period, third period, fourth period, fifth period, sixth period. Take for example this one. So its electronic configuration ends at 6s2 and 6p3, 6p3. See, as outermost shell, these electrons cannot participate in bonding due to the presence of inner core electrons. The valence electrons cannot easily participate in bonding due to the presence of inner core electrons. That particular effect is called inert pair effect. Very simple. Due to the presence of inner core electrons in heavier elements as you come down the group, the valence electron does not participate in bonding. That particular effect is called inert pair effect. I think you are very clear about the shielding effect or screening effect and inert pair effect. Okay, we shall continue. So therefore, there is a lot of diversity in the properties of p block elements. Okay, in order to understand p block elements very clearly, we have to study in first field study some part of chemical bonding, entire chemical bonding topic to study. We shall discuss some part which is necessary for our discussion. So what are the different types of bonds you study? So we have ionic bond. Ionic bond. So ionic bond is formed between the more electropositive elements, that is S block elements, and more electronegative elements like P block. Take for example NaCl. See sodium. So its electronic configuration is 1s2, 2s2, 2p6, 3s1. Take for example chlorine. Its electronic configuration is 1s2, 2s2, 2p6, 3s2, then 3p5. Okay. So this is nothing but a sodium, and this is nothing but a chlorine. See, in order to form sodium chloride, ionic bond is formed by the transfer of electron. So here, sodium ionic bond lost one electron. It gives one electron. It transfers its electron to chlorine. So chlorine atom, as its outermost electronic configuration is 3s2, 3p5. See, only one electron is required to attain noble gas configuration. So therefore, it can easily receive one electron. So we have the configuration with Cl minus, and we have the ionic solid, which is sodium chloride. See, you go through the electronic configuration of these, and it attains here A, and it attains here B, noble gas configuration. So therefore, all ionic solids are stable. So chloride ion forms by gain of element. See, chlorine we have to study in 17. So that is the basic thing. Why ionic solids are stable, which gives a high melting point and boiling point, which can ionize in its aqueous solution, good conductor of electricity in aqueous solution. Okay, so these points are to remember. In ionic bond, some characteristics of ionic bond. So ionic bond is formed by the transfer of electron. And when the compound is formed, both atoms attain noble gas configuration. Therefore, it is stable. Okay. You have to more concentrate on covalent. See, covalent bond is formed between atoms by sharing of electron. See, take for example hydrochloric acid. Say which is in gaseous state. So H plus and Cl minus. So there is electron cloud here shares, and this is nothing but a covalent. And now it attains electron cloud is towards chlorine atom, therefore it attains partial negative charge, and this attains partial positive charge. See, here not a charge directly plus or minus, like ionic. What is ionic? Transfer of electron, and here sharing of electron takes place. See, this chlorine atom receives one electron, and the electron share as the molecule is stable. Therefore, how much electronegative character it attains, same amount of electropositive character attained by other element. That is the main thing. And both the molecule will be neutral. This particular is called covalent bond. So you can observe covalent bond in the diatomic molecules like dinitrogen, oxygen, hydrogen. So here nitrogen forms covalent bond with another nitrogen atom. See, sharing in nitrogen we can find triple bond. We have 5 valence electrons are there. So this is nothing but a nitrogen molecule. Where the electron distribution in the both atoms is similar because electronegativity is the same. Both are same electron. In any diagram molecule which is formed by the sharing of electrons, all are neutral and equally electron displacement takes place, electron transfer takes place, electron sharing takes place. So actually in covalent bond electron sharing. So here both electronegativities are same. Therefore, in the diagram molecules, take for example oxygen, O2, which is nothing but we can find two bonds. So oxygen valence electron is 6. See, two are pair here. So this is nothing but oxygen. So here in covalent bond, why formation? Again, I am going to take an example of hydrochloric acid. Here we can find due to the more electronegativity, electron flow is more towards chlorine atom, and here electron positive pair. Now, this particular difference, this difference is due to electronegativity difference between two atoms. As electronegativity is more towards chlorine, the electron cloud is attracted towards it and it is partially positive. And we can find here an dipole moment. See, you have to study in covalent bond. You have already studied in university. Dipole. What do you mean by dipole moment? See, come to this example, particular example. See, dipole is nothing but so the electron is shared more towards more electronegativity. So this is nothing but the direction. You find the direction. So it's a vector quantity. Dipole moment is a vector quantity. And here in the dipole moment, the element which is more electronegative, that side electron cloud. Actually, this is molecule. This is nothing but an HCl molecule. You can find more number of electron cloud is towards more electronegativity. And these type of compounds are called polar compounds. In covalent bond, we can find polar compounds. See why these are polar? Polar arises due to the electronegativity difference. As chlorine is more electronegative, the electron tends towards it. So this is nothing but it exists as a polar molecule. In polar molecule, you can ionize in aqueous solution. You can ionize. See, non-polar molecules are non-polar molecules. Non-polar molecules. See, take for example water H2, which has a bent structure, and oxygen and two hydrogen atom. Actually, oxygen atom is sp3 hybridized here. It should show a normal tetrahedral angle 109.5, but normal tetrahedral angle is restorated due to the presence of two lone pair. All these you studied in first week. So we can find therefore. So this contains partial negative charge, partial positive charge, partial positive charge. So dipole moment, as its electronegativity is more, and these also directed towards oxygen atom, and it shows maximum time. All is studied. So all these basic concepts you will come across in different examples. Why certain compounds of p block elements are polar? Some say it questions we will going to get. So here, see its bond angle is reduced to nearly 1.4, 104.5. Even though it is sp3 hybridization, due to the presence of two loops, and it has bent structure, and its bond angle is reduced to 104.5. So we can find the more dipole. So you take for example boron trifluoride. studied this example. In boron trifluoride, net dipole moment is 0. See, as fluorine is more electronegative, so dipole moment is equally 120 as this wrap extends in this side but in number and net resultant dipole is 0. So there are therefore P of the molecule is non-polar. Like the carbon dioxide. See, it is nothing but a compound of oxygen in 16 carbon dioxide, which has a linear structure. Carbon is the central atom and both oxygen atoms dipole moment in the equal in opposite direction. So net resultant dipole is 0. So dipole moment of any compound can be measured by debate. You know it, we studied in first year, but you have to remember dipole moment and covalent compound, polar covalent compound, and non-polar covalent compound. So we have to study next. As in P block element, the covalent bond character, ionic bond character, we come across. See, covalent bond is nothing but sharing of electrons. See, in the sharing of electrons in a nitrogen molecule, in oxygen molecule, in fluorine molecule, we can easily apply. See, oxygen molecule is a non-polar one because both the oxygen atom has same electronegativity. Then in B block, we shall discuss our points according to their syllabus, which is nothing but 15 group elements. Say important 15 group elements are nitrogen, phosphorus, arsenic, antimony, bismuth. See, nitrogen, first we have to study some basic things about this. See, as nitrogen is a non-metal, phosphorus is also a non-metal, arsenic and antimony are metalloids, and bismuth is a metal. We already told there is a diversity in the properties of P block elements. Generally, we are telling P block elements are non-metals. In 15 group itself, we are going to find here non-metal, metalloid, and metal. Why this diversity takes place? It takes place due to small size, high electronegativity, high ionization enthalpy, more electron gain enthalpy, and unavailability of d orbitals. See, unavailability of d orbitals in the second period. If you go from third period onwards, there is an availability of d and f subshell. Therefore, there is a lot of difference between these elements. Again, the poor shielding or screening effect and inner pair effect also plays a role for the diversity in properties of 15 elements. So, nitrogen is non-metal. Phosphorus is also non-metal. Arsenic, metalloid. Antimony is also metalloid. And bismuth is metal. So, bismuth is metal. What is the reason? See here, after third period elements, that is from arsenic, antimony, bismuth. See bismuth. As you come down, electronegativity decreases. electron gain enthalpy is also decreases, and due to the present pure shielding of D and F electrons, and due to again inner pair effect, this one behaves as a metal. Antimony and arsenic are metalloid, and these nitrogen and phosphorus are non-metal. So why these shows non-metallic? Why nitrogen is quite different, and that difference in properties is called anomalous behavior. Anomalous behavior of nitrogen. That means anomalous means difference. Even though they are placed in 15 group elements, but nitrogen is different to other elements. Why? So important reasons are, see, nitrogen due to small size, high ionization enthalpy, more electronegativity, and electron gain enthalpy. So electron gain enthalpy is also more, and unavailability of d orbital. So another one is unavailability of d orbital. Are you clear? So these are the anomalous behavior of nitrogen. Due to this characteristic, nitrogen is anomalous with other elements. Due to small size, high ionization enthalpy, electronegativity, electron gain enthalpy, and unavailability of d orbital. Because nitrogen is a second period element. In second period, we have solution 2s and 2p. So 2p orbital does not exist at all. So we have only covalency 4 and you studied that covalency. As a small size, electrons are tightly held towards nucleus. It is very difficult to remove electron. So therefore, its ionization enthalpy is more. So due to large amount of ionization enthalpy, so it is behave as a non-metal. What are the criteria for a non-metal? It must be a small size and ionization enthalpy should be more, and electronegativity. See, nitrogen is more electronegative than many elements, but it is less electronegative than fluorine oxide. Again, due to electronegativity and electron gain enthalpy. See, as there are p block elements, which is in 15 group, again deficient in 3 electron to attain noble gas configuration. So therefore, it can easily receive electron. Therefore, the electron gain enthalpy is also more. As a small size, addition of electron takes place. It never repels that electron, it receives that electron in order to attain noble gas configuration. So therefore, electron gain enthalpy is also more. And non-availability of d orbital. Say, as it is the second period element, there is no chance for next vacant orbital. So therefore, this is what is an important criteria about the anomalous behavior of nitrogen. So therefore, unavailability of the d orbital is these 4 characteristics you have to write it. Every year we will ask question about why nitrogen is anomalous with other 15 group elements. It is due to small size, high ionization enthalpy, more electronegativity, and high electron gain enthalpy, and unavailability of d orbital. Okay. So this is the first concept which we studied in between the elements. So we shall study one by one with other elements. With other elements. See, nitrogen, its electronic configuration. Its electronic. First, we shall study electronic configuration of nitrogen. So, which is nothing but 2s2 and 2p3. If we go for phosphorus, 3s2 and 3p3. Arsenic, 4s2 and 4p3. Antimony, 5s2, 5s2 and 5p3. Then bismuth, which is nothing but 6s2, 6s2 and 6p3. See, these are nothing but the valence electrons. Valence electrons. See, all contains 5 valence electrons. See here, so this is second period, this is third period, fourth period, fifth period, sixth period. See, in the fourth, fifth, sixth, the inner electrons are more by 3d, 4d, 5d, and even by 4f and 5f. The inner 4f, the inner core electrons are more. As large number of inner core electrons are there, it gives an influence towards nucleus and outermost electron, valence electron. And then shielding, that poor shielding due to the orbitals, that is called screening. And again, you have to remember inner pair. See, outer valence electrons not easily form in bonding with other compounds due to the presence of inner core electrons. That particular effect is called inner pair. See, we can find by knowing the electronic configuration as all are p orbital half-filled configuration, So it is these 2s and 2p they can participate in bonding easily because inner electrons are very less. Most important point we have to remember inner pair. Due to inner pair, as inner pair effect increases as come down the group. So therefore, this will behave as a better. And why there is a diversity in the same group? There is a diversity. See, again, it is due to the screening effect of d and f electrons, which is nothing but poor shielding. Okay. So this is nothing but the electronic configuration. See, as in the electronic configuration, nitrogen 2s2, 2p3 is nothing but a half-filled electronic configuration. And generally, all 15 elements shows electronic configuration ns2, np3. They shows ns2, np3. So, as this new electronic configuration is one of the characteristics, entire 15 elements you have to study the general characteristics regarding the electronic configuration, atomic and ionic radius, electron gain enthalpy, ionization enthalpy, electronegativity, and these concepts we have to study for the entire all the elements. These are the basic characteristics. Okay, we shall go for ionization enthalpy. See, ionization enthalpy generally the 15 is more than in 16 group element. See, yesterday we discussed about the electronic configuration of nitrogen and oxygen. See, among the nitrogen and oxygen, in ionization enthalpy, nitrogen is half-filled electronic configuration. Nitrogen shows, say, nitrogen, which is nothing but 7, 1s2, 2s2, 2p3. Oxygen A, 1s2, 2s2, 2p4. See, as it is half-filled configuration, It is very difficult to remove an electron because it has a saturated content. All the three orbitals are contains one each electron. If you in 2p orbital in oxygen, so again 350, 1, 2, 3, and one is paired, and it is nothing but a particle. See, uniformly energy is distributed here, all the three orbitals. So therefore, ionization enthalpy is little bit more. As along the period, ionization enthalpy increases, but there is a small change between nitrogen and oxygen because of interaction. So ionization enthalpy as you come down the group in 50 group elements, ionization enthalpy decreases. Again, it's a simple analysis due to increase in size. As increase in size, electrons are loosely held towards the nucleus. By supplying small amount of energy, we can easily remove the electron. So therefore, in 15 group element, as you come down the group, the ionization enthalpy decreases. Ionization enthalpy of nitrogen is more than phosphorus, arsenic, antimony, bismuth. Okay. So this is the ionization enthalpy of 15 group elements. Your first ionization enthalpy, second ionization enthalpy, third ionization enthalpy, it goes on increases according to the order. See, more than three elements, it is very difficult to obtain. Three electrons. See, first ionization enthalpy, second ionization enthalpy, third ionization, there is a variation in those ionization enthalpies as the number of electrons decreases, the nuclear charge increases. As proton will remain same, nuclear charge increases. The outermost electrons are tightly held. Again, it requires more energy. Okay. Then electronegativity. See, electronegativity of nitrogen. Electronegativity of nitrogen. Nearly, it gives it shows a value 3. So nitrogen, phosphorus, arsenic, antimony, bismuth. See, electronegativity decreases down the group. Nitrogen shows highest electronegativity in this group. As electronegativity decreases, electropositive character increases. So therefore, metallic character increases. Again, bismuth is a metal because due to decrease in electronegativity. Okay. Then electron gain enthalpy. Electron gain enthalpy. See, electron gain enthalpy of nitrogen is more. So, electron gain enthalpy of phosphorus is still more. Again, electron gain enthalpy goes on decreases. See, there is a large amount of repulsion. Why? The electrons with the same orbital. So therefore, so as you come down, electron gain enthalpy is also decreases. Due to increase in size, the outermost orbital contains large number of electrons. Inner core electrons are there. Readily electrons it cannot receive. Again, size increases. In 15 group elements, as you come down the group, electron gain enthalpy also decreases. See, electron gain enthalpy of third period elements. See, nitrogen and phosphorus. See, phosphorus shows more electron gain enthalpy. So there is one. Yesterday we discussed about electron gain enthalpy of fluorine and chlorine. See, as it is in the 3p, in the 3p load and 2p, see, which is smaller load, already electrons are there. If again, it cannot easily receive the electron, there must be some repulsion. Then, as you come in the third period, like phosphorus, so third period, the lobe is more size, and it can receive them. That is one of the small energy of the primitive. Okay, then arsenic antimony. behave as a metal alloy. They behave as a metal alloy due to poor shielding of again their d electrons and as well as f electrons. So we can find the many diversity in these. So therefore, nitrogen and phosphorus is a non-metal, arsenic and ammonia are metalloid, and bismuth is a metal. So we are applying the fundamental characteristics, electron configuration, atomic and ionic radius. As you come down, the atomic and ionic radius increases due to the addition of shell, new shell. Then ionization enthalpy, as size is more, as you come down, ionization enthalpy decreases. Electron gain enthalpy is also decreases. Electronegativity is also decreases. As electronegativity and electron gain enthalpy decreases, electropositive character increases. So therefore, this is better. Again, other reasons you have to remember why bismuth is better. It is due to inert effect as well as poor shielding of inner particle. Okay. Why nitrogen is anomalous with other elements? It is also due to small size, high ionization enthalpy, high electron gain enthalpy, more electronegativity, and unavailability of d orbital. The separate notes we are going to get. Okay, we have to study the next part of 15 group elements. Part of 15 group elements. In 15 group elements, the general characteristics we study. So you have to study for all the p block elements reaction with oxygen, reaction with hydrogen, reaction with halogen, and reaction with metals. So these you have to remember. All p block elements 15, 16 and 17. The fundamental reactions or chemical reactivity between hydrogen, oxygen, halogen and metals. How they react, how they will form a compound, what type of compounds they form. And we shall study this in next class. Okay, in yesterday, our board is somehow shining and slowly we will deliver the syllabus. Actually, P block element syllabus just we started. Some of the basic points you have to remember, and all the elements which is present in P block, just to write whatever we wrote on board, and as soon as separate notes is sent, write that in a separate notebook. Whenever we ask, you have to show. See, while delivering the online class, we see the views. Only nearly 100 or 150, 160 students are watching at that time. Any problem in accessibility of internet or anything which you find difficulty, just put a message in group and be in touch with the study. Due to this COVID-19, see, our college should start at the end of May, June, July, August. Probably it may start on September. Let us see what will happen. But every day we are trying to send you the online class. See, whatever you study, just go through it, make some note. Any doubt, you can ask. While writing on the board any concept which you not understood, we can put a question on in your group that we can answer. Okay, dear students, have a nice day. Thank you.